We'll now continue with section 1.6 and begin discussing compound inequalities. We're going to explore these inequalities in the terms of several application problems. So let's begin with this example. The final grade in a class depends on the grades of 5 exams, each worth a maximum of 100 points. Suppose Janice's scores on the first 4 tests are 67, 82, 73, and 85. What scores can she make on the 5th test to get a B in the class? So there are 2 things here that we need to sort of be aware of. One is how the grades will be averaged. So we know that if she has 5 exams, and we already know that she's made a 67, an 82, a 73, an 85, and whatever she makes on the 5th test, which we're going to call X. We know that to find the average of those 5 test grades, that we would add them up and we would divide by 5. So we want to keep that in mind, that that's how the average is going to be calculated. We also want to be sure that when we calculate that average indicates that she's going to get a B in the class. So what does that mean about her grade? That means that this average has to be between an 80 and a 90 in order for her to have a B in the class. So her average has to be less than 90, and her average needs to be greater than or equal to 80. And so we're going to set up an inequality like that to solve. So now that we have our inequality set up, how do we solve it? We know that inequalities are just like equations in that they are easier to solve if they are not in fraction form. And so we can get rid of our fraction by multiplying this inequality by 5. Now, when we multiply the inequality by 5, we want to multiply all 3 parts by 5. So we're going to multiply the 80 times 5, and that's going to give me 400. We're going to multiply the 90 times 5 on the other end, which is going to give me 450. And we're going to multiply this fraction in the middle by 5, and when I do that, the 5s are going to cancel out. So in the middle, I'm going to still have the 67 plus the 82 plus the 73 plus the 85 plus X, but the denominator has been canceled. So if we add those numbers on the top in the middle, we're going to end up with 307. And so I'm going to go ahead and simplify this. 307 plus X, and we want that to be between 450 and 400. And so now let's look at how we're going to solve this. We want to solve for X. We want to get X by itself. So we need to get rid of this 307, so I'm going to subtract it off. And so 400 minus 307 is 93. And 450 minus 307 is 143. So what this tells me is that her score on the 5th test needs to be, and let me take care of that right there, I didn't mean to put that there, that her score on the 5th test needs to be between 93 and 143, but we know that they've already told us that the test scores cannot be more than 100, and so in actuality, her test score needs to be between 93 and 100. And so if we're going to write this in terms of acceptable test scores, we would have a bracket on the 93, because we could equal the 93, but we'll go all the way to 100, and we're going to put a bracket on the 100 as well because she can equal the 100. So those are the acceptable test scores. If we want to put it on a number line, we would mark off the 93 with a bracket, and we would mark off the 100 with a bracket and shade in between. And again, we have to reduce this 143 to 100 because we are told that the test scores cannot exceed 100 points. And so this inequality is called a combined inequality because it has three parts. And so let's look at a couple of other examples on these combined inequalities. Our first one says -1 is less than 3 minus 2x, which is less than or equal to 5. And so if we want to solve this, remember our goal is to get the x in the middle by itself. So we could begin by subtracting 3 off of all three parts of the problem. So that's going to give me -4 is less than -2x is less than or equal to 2. We then are going to divide by -2. If we do it in the middle, we need to do it on all three sides. And also remember that if you divide by a negative, that your inequality is going to change directions. So this -4 divided by -2 is going to be 2. This less than is going to turn to a greater than. In the middle, we'll just be left with the x. We change the inequality on the right-hand side as well to a greater than or equal to. And 2 divided by -2 is -1. And so typically we will see this sort of turned around, doing the -1 first and the 2 on the right. Okay, usually we have the smaller number first. All right, if we wanted to write this in interval notation, we could write it starting with -1, going all the way to 2. Because there's an equal sign on the -1, we'll use a bracket. Because there's no equal sign on the 2, we'll use a parenthesis. All right, so let's go ahead and look at part B of this problem. Part B says 2 times the quantity 2x minus 1 is less than or equal to 4x plus 2, less than or equal to 4 times the quantity x plus 1. So again, we're going to start by doing the distributive property and distributing this 2 through the parenthesis on the left and the 4 through the parenthesis on the right. So 2 times 2x is 4x. 2 times -1 is -2. We'll leave the middle part alone. On the right-hand side, distributing, we're going to have 4 times x is 4x, and 4 times 1 is 4. All right, so let's begin by starting to move terms around. If we want to simplify for x, we're going to begin by subtracting the 2 from all three sides of the expression. So that's going to give me 4x minus 4 is less than or equal to 4x is less than or equal to 4x plus 2. Now, the interesting thing to note here is that you do have a 4x in all three parts of this inequality. And so if you were to go in and you were to try to isolate the x in the middle and divide by 4, or even better yet, divide by 4x, you're going to have that variable fall out completely. So look at what happens here. If we divide by the 4x, okay, so dividing by the 4x, as we said, now we are going to have to divide that whole side by 4x, which is going to get pretty messy pretty quickly. So I actually think I'm going to go back and I'm going to adjust what I did just a little bit up here at the beginning. I do notice that there's a 4x in all three parts, and so I know that I'm going to lose that. Since these 4x's are added and subtracted on, I'm going to go ahead and subtract that off, and maybe that will make it a little easier to deal with. So if I subtract 4x from all three sides, then that's going to leave me -2, which is less than or equal to 2, which is less than or equal to 4. Now, looking at that inequality, I notice that it is a true statement. -2 is less than or equal to 2, and 2 is less than or equal to 4. And since we're left with a true statement, we know that the compound inequality is going to be true for all values of x, And so the solution set is going to be all real numbers. And so we could say that our solution set runs from negative infinity to positive infinity.